That's all I'm just thinking of. So I just went on again and thought of generating some more information out of my messages this time. I just thought of applying some functions over it, let's say length. Like yesterday also we were talking about this particular function, the apply function in pandas. Actually, it is something that will be going to the each and every element of my entries and will be performing a particular function that I do provide. So it's like if I provide length, that is the length function in Python, it will be finding out the length of each and every message. So as soon as I do this, it is returning me all of the data. So it's like providing the length. I might be a little interested if I could just compare the length of different types. So I want to see the distribution because this is some sort of numerical data I've obtained. So I'm interested. So how would I be doing it? I would just say create a new column named as length. And this is how I'll be doing it. Now I've got my data in this fashion. So this looks interesting, but how can I really analyze it? I've got a couple of ways. Either I could just again group by my data, group by, and grouping by type, dot describe. This time I'm interested with my numerical stuff only. And when I describe it, I do see ham messages are generally of 70 characters. And the mean length of the ham messages are 71. Whereas the spam messages are like 138. They're utilizing the entire limit actually. Because in general, we see the messages are like 140 characters, limitation over there, but not really necessarily here. Similarly, if I talk about the standard deviation of ham messages, that is quite high. That means we're going to see a huge, disparity in terms of the length. Like minimum is just 2 characters. It could be okay, I guess, and maximum is 910. So ham messages are like having a lot of variance, I should say, in terms of the number of characters. Similarly, when I talk about the median lies around 52, and first quartile is actually around 33, and third one is 93. And if you talk about the spam ones, it lies around 28.9 approx. That's like slightly lower, and minimum starts from 13. So spam, okay. So spam messages are like at least having some words for sure, and the maximum looks like 223. So they're also like having some longer versions, and that is like provided here. The median is actually lying around 149. So this is something slightly confusing. I mean, like what could be derived from this? Maybe something yes, no. But let's have another view on this. Let's do some little graph thing here. So I'll plot some graphs. How would I be doing it? I need library here. On define library and definitely the matplotlib version. Plot CLT. These were the couple of libraries we've been using yesterday as well. Cbon and matplotlib. Heading towards these things, and first up, I'm just importing them. They are done. Let's draw some graph here. Let's just try this SNS dot this plot. If I could just do again, because this is something going to provide me a histogram. Could just go with the his plot also. That would also be doing for me. I need the data first up. This is my df. Second argument, I require x and y here. So I'll provide my x, let's say, and that is the length column. I'm interested in the length column, and also I'll provide the hue. Hue is like kind of group by thing. In graphs, if I want to segregate my data, I can use the hue. So I'm providing the type here in my hue. Let's just wait for concept. So it came out, but not really clearly visible. So I'm doing a little formatting on my graph now. Firstly, I would say let's create a bigger figure that is something having a fixed size. I should say this should be 18 by 6. As soon as I do this, it will be making my graph bigger, and 18 seems like still less to me. So I can just say 20, much wider now. Okay. Second option, I'm thinking of doing it, let's say some grids. So it will make my graph more interesting to me. It looks cool. Now let's focus on this. What we're really getting here. So I can have one more thing here. KDE part if I have. We can do this. KDE. And it seeks a couple of things. XY shade. Do we have ruler? Doesn't look like. Let's just try x equals to length. I'm thinking of data equals to df. Plot it. Seems that it's not going to work out for me. Let's remove it right now and just focus on this thing only. So what am I getting? It's having a couple of things together, ham and spam. So blue one are the ones that are like the ham, and this is the histogram. Histogram is basically all about, providing you the counts, frequencies rather. So most of the ham messages are actually, below 40 characters across. Let's just break down this particular Excel. What am I talking about? Let me show you. I'm just thinking of creating X text of my choice. Right now they are like 0 to 800, 900 so, but I'm thinking of breaking it down. Let's say a range function I'll be using and asking it. Let's do it with 950 and set that up with a gap. So start from 0, 950 and the gap of let's say 30. Then just don't really show me these outputs, just generate. Looks meaningful to me. I guess I have not broken it down. Yeah, it goes well. So what have I done? I just mentioned the ticks here, so I could just break down my data, understanding a little further. And here I can check it out. Most of the length of my ticks are around 20 to 60. 20 to 60 characters in a message. They are generally the hem type messages. But when I talk about spam messages, they're generally like 120, 30 to 160 or 70. That's like the category I'm having here. Like spam messages are not shorter, they're like slightly utilizing the number of characters. Whereas this ham messages are like shorter because generally we do a communication conversation kind of thing for the text SMS and all. So this is sort of, insight we could just try from our data set. Now, what else I could do here? Actually, I'm left with nothing because we just write some text straight up, could see it fit, but this is not good enough because just choosing the length, because we are having a lot of messages having the length of 30, 60, 90 for the spams. So this is not a clear view because there was some disparity in the number of messages as well. It's like 4,800, there's a 746. So I can't be so specific here whether it would be a good choice of discriminating the data. And in fact, one more thing that we could notice here, there are some blue bars also in this particular category where we are having this orange one. That means the length is slightly segregating the things up, but not very clearly about my text data. So this numerical information is okay, but not good enough for text classification, or like I should say, I cannot say this is my important, like the only important feature that is going to help me out for text classification. So I need to do some more efforts with this. And that effort is actually going to be done with the NLP, natural language processing. So this is what I'm bringing up natural language processing into the data. So the very first thing I should know, like what are the key steps, what are the key things that I could really go and do here. So let's get back to this thing that I was talking about. When I say natural language processing, in Python, they have provided us one library named as NLTK, Natural Language Toolkit. This is a very big library and like having a lot of things. And like when you install this, I mean, like this is not by default installed in Jupyter. It is having like certain features, but not all. So we need to be like hitting that up if not available in your system. And how we do it in Jupyter, we have got one command procedure. You can use exclamation symbol, then pip install NLTK. That's like the command providing thing. So through this, it will be seeking up the internet connection. Definitely, it will be downloading from internet, and it might take some time if it is like not installed in your system. In my case, it is already, so it is just suggesting me requirement already satisfied. Otherwise, it would have taken some time. Apart from this, if I just wanted to utilize, so I can use this NLTK, import NLTK, and again this might take some time. And now I've got one function named as NLTK.download. Now this is something like even after installing this library, there are a few more components the NLTK library seek. So by default, they generally do not install automatically. So you need to install them, and that's like around 800 900 MB stuff. It's like as I said, it's a big library. When we say like programming languages like Python, and they're having libraries around 800 900 MBs, that you can imagine like it's a very huge library actually. Because in general, we do get library files around I mean like maximum 1 MB or 2 MB or so. But it's like 800 900 MB. That means it's having a lot of data also. Let's see, like if I hit this particular function up, what will be coming out in front of me? It will be opening up. Let me just get showing anything. Should open up. Not yet. I know it got. So it opens up this little thing, and what is suggesting here, like packages. So there are a lot of packages, and in my case, it is suggesting few of them are like a little outdated now. In fact, I've installed all of those, but still it's suggesting few of them like out of date. So I could choose them and ask it to download. Please download that for me like that. So currently, I won't be doing it. It will be taking longer, so I won't be doing it. But yes, in your case, if you feel like you should be doing it, and without that, you won't be able to use them. So I would recommend if you want to use NLTK, you should download all the packages. Otherwise, in every step, it will be asking you like this is not available, download that. It is not available, download that. So you will be doing it again and again. Instead of that, you can do it one shot. So anyway, like this is what we could use, and after downloading it, you can simply close it. So that's like a little GUI tool. It will open up after hitting this particular line. If not required, you can simply comment this, and we can move further. So I did it, but why did I do these things? Because I'm looking for NLP. So how does it really do the things for me? So it's like a little code snippet I'm just showing you, because it will give you a little idea. Like we will be importing the libraries, might be like downloading few of the common things that are required, just like the stop words if I'm thinking of, and maybe just fetching some text from somewhere and then doing some process. So this sort of process actually having some sort of steps, I should say. And what are those? These are the ones. Steps, like by default, whenever I'm getting the text, firstly I should be like doing sentence tokenization. Now what is sentence tokenization? It's quite simple thing. You can simply break down your text and it will be generating some the sentences like based on some terminations that we put in the sentence. After that, we will be looking for word tokenization. So each sentence will be broken down into the words. So this is a very simple thing actually. But then after, we have got some optional steps, as in we'll be doing some text pre-processing. I just like yesterday we were doing it on the data that was numerical, but still we were doing some text pre-processing onto this. And here in case of text, it could be text lemmatization and stemming. As in, if I'm looking for no some common root words, like we see good, better, best. They all are like talking about the same thing, like in a good sense, a positive sense. So if I'm interested into the root word, sometimes the verbs different forms, like different forms of my word, like going, go, when. So I wanted like the root word only. So finding out the root word from the different forms of the word and the different orders of your word, then we go with lemmatization and spelling process. So that's like optional thing, not necessarily every time, but yes, this is what we can do. Apart from this, we see a lot of stop words in the text. Stop words as in like I, we, might, will. These words are not going to make huge impact on like differentiating. Like when I say the analysis of sentiment, or like if I'm just trying to understand like classifying my text, because whenever like I'm like reading out a particular text, we do see some keywords from them. Like any sentence having certain important word, like I am busy. If I say I am busy, so what makes an impact on my mind is like busy. So that's my important word. I am busy, or like you're busy. I don't really care right now. I'm interested. It's like busy. So that sort of approach, whenever we are looking for, then I would say the stop words are not at all required. So I would be removing these. So this is like one of the key steps, like removing these stop words. Then after, we can do some further pattern identification, like any particular sentence or like word having a certain pattern. Maybe I just want to remove it. I just want to catch it. Could be anything. And that can be done with the help of regular expression. It is like very powerful string utilization tool in most of the programming languages. So regular expression thing we can use. But yeah, after doing all these things, we are again left with the words. And those words, like after the word tokenization I was talking about, just like after sentence tokenization, I went on this word tokenization. It will be ultimately generating some words, all the like different words from me and different messages. If I do compare that story with the messages, so I would be getting all the words distinctly. Then after performed like lemmatization and stemming, so as removing the stop words and finding out some patterns. So I've done all these things. Then after, I might be interested in creating the bag of words, just like preparing the seed boxes, and we might be then just labeling them. Who belongs to this or this. So bag of words is quite interesting thing in that we will be just asking it like each and every word in each and every message. So it will be suggesting me like which word is coming in which particular message and how many times. That's like the bag of words, like a little uh, pivot table, I should say. Like if I'm having word one, and this is message one, word two, message two, suppose. So now, if word one is present in message one, then how many times it was there? Suppose it was three times. Was that word two present in word message one? It is, let's say, no, zero. Was that word three was present in message one? It is yes, one. Similarly, in message two, do we have this one? This is one time, this is like zero time, or like maybe two time, and this is like three times. So it is something like we call it like bag of words. So this is going to be a numerical feature for us. I was looking for. I mean, like this is going to tell me for each and every word in terms of the count. So counting is not good enough, definitely, but at least I would be getting little detailed information of my text. Then we would be thinking of if I could get more important information from these counts, then it comes out this particular thing. TF-IDF. This is term frequency and inverse document frequency. And this is quite important, I should say, because this will be actually, deriving and suggesting me like what could be really important for us. So what we really do calculate here, let me just take you further to that particular slide. Here we go. Okay. So let me just move the text first up. Here we go. So TF-IDF is basically like combination of both the things, term frequency and inverse document frequency. Individually, they are like this. Term frequency is like the name itself suggesting how many times the term appears in a particular, message. When I say the term document, that is like the message, and total number of items in the document. Suppose a particular message is having total number of 40 unique words. After creating the bag of words, I could just find out 40 unique words. Out of those, I'm talking about one particular word. So one particular word, like how many times it is coming up? If it is like 3 times, so it's like 3 upon 40. Unique words in like on the total number of words, not the unique words. I'm saying like total number of words. So it is having a term frequency that is 3 upon 40. And quite simple it is. But when I talk about the inverse document frequency, it suggests total number of documents, means total number of messages. Let's say we have 5,000 messages here. So it would be the total number of messages divided by number of documents with that particular term in it. Let's say a particular word that was 3 times in that particular first message. So this particular word is like repeated how many messages? Let's say there were 3,000. Then take a logarithmic of this. So this is going to be inverse document frequency. And what is the significance of having this inverse document frequency? It will be telling me how less important the word is. Means if a word is repeated in most of the messages, that means it's a very common word. Not interested in that. I wanted the key word that is impacting and like justifying, really telling me this is the basis on which you can say what category it belongs to. That means this is very important. Inverse document frequency. The less importance of my word will be coming out of this. So I'll be just multiplying both the things together, TF and IDF for a particular word. And eventually what I'll be getting would be my TF IDF for a particular thing. And that's what I would say. Instead of the count of the words, I would rather be interested in their, term frequency and inverse document frequencies. Get this? I'll use it as a feature. And if I'm provided a feature, that means I can apply my machine learning algorithms there. And we saw like a couple of algorithms yesterday. We might talk about one more today, and we'll use that. So let's do follow these steps all together, and like whatever we feel like necessary here, if we're doing it, let's see if we can get some output of this. So I'm heading back to my code now. These are the key steps I'll be doing for sure. So coming back to this, I have imported my library NLTK. So just thinking of doing some efforts with this. What sort of effort? It is definitely the sentence tokenization, word tokenization. So I'm creating a function here, DEF, let's say, and I would say text pre expecting some text inside, and then after I'll be thinking of doing, let's say, sentences I wanted to bring up. So I would say this is sentence equals to NLTK dot sentence tokenize. That's my function, sentence tokenize. So it will break down my data into different sentences. Let me just show you how would that be coming up. So just created the function here and just creating a sample message. Let's say sample message. And I'll be choosing any of my message randomly. Let's say 1001. I don't know which one is that. So let's just see that. Okay, this is quite not much length it is having, so I'll just go with the any other one, maybe 1100. Yeah, this looks fun. So let's give it a shot. We will try this out. So sample message. So I would say text pre-process, the sample one. So what really comes out? Okay, I didn't pass out my text here. So what have I got? I've got a list. When I tokenize my sentences, this is coming out as a list, and it is having like couple of things inside. This is the first sentence, and this goes like second sentence to me. And it was like slight obvious. I saw it now. I watch TV, watch until I forgot to check my phone. So this is slightly broken English, but it's okay. Let's do carry on the process. So what am I going to do now? I'll just say for SN sentences. So that's my sentences are going to be there. Along with this, I'll do one more thing. Like in prior, I'm knowing this, like I should be converting my text into the lowercase upfront, and now suggesting it, can you do the word tokenization for me? So it will create the words by simply nltk.word tokenize, and let's just print those words. Or maybe I can just ask it to store them up W's, let's say a list, and asking it, please append the words into this. Let's see what really comes out, and this time I'm interested in seeing the W's. So I have just modified my function and asking it again. I think I'm missing something here. Once again, why did I miss this again? So I've got my words broken down here, and it looks like done, but there's slight mistake, and that looks like it's having multiple lists formed up. I just wanted that to be a single list. So instead of append, I would prefer my basic approach, that is this one, plus equals to, because the words are going to be itself some lists. It looks cool now. So the words been broken down. Now, as soon as I see the words, I would be interested finding out a lot of important things from this. Before that, I need to remove some useless things. As in, this triple dot having no use here. These stop words, these numerical ones, I just don't want them. So how would I be really doing this? Firstly, I would import library, and that should be from nltk dot corpus import stop words as SW. So I've imported this one. Let me show you what it really produces. SW, and it is having, I think this is the words, and I'll provide the language here. Like I wanted the stop words for the English language, and just wanted to see, let's say, top 10. These are the stop words. They are saying, I, me, myself, we are, us, ourselves, you are. And if I just check out all the other like words, there are so many actually. So I don't want to just, you know. So you can see all these words, they have put into the category of stop words. And I am interested in removing those. So I'll do this. Second thing, what I'm seeing here, like a lot of punctuation symbols here, a lot of numbers also. So I would just use a couple of things. First thing is from, if I say from string, import punctuation as punc. What is this? It's having all the symbols, just symbols. I could do this manually as well, but since they have provided me, I'm using this up. So I've got the punctuations, I've got the stop words, and I would ask it now, please remove those ones. I don't want them. So how this could be done is this can be done like I can ask it W's, just modify the W's by using a list comprehension here. Here we just create a list, and it would be having some words W for W in W's, but on a condition. What is the condition? If that word is not in SW dot words, from English. So if it is not from that, remove it. Then after, what I'll be interested into, I would say, uh, whatever we have created here, W's, let's just connect them together like this. Dot join. Let me show you what will be coming out of this. It has removed all the stop words. Also, it has made like entire sentence once again, but definitely not having those stop words. I've joined them together with a space. Why did I join this? Because I wanted to remove the punctuation symbols also, and I am thinking of doing it like this. Let me show you. I would again asking you what to do here is join and make it W for W in WS if W not in func. Actually, that is not W anymore. This is CH. That's the character we're finding out from itself. So just making a little meaningful name here. And then joining back as a string. And then splitting that with the space. Let's see what really comes out. It came out again as, you know, list, but still having some problems. Let me just see what really went wrong here. Let me just check before splitting. Okay, we've got extra spaces there. So I needed that to be removed. Firstly, I'll split it. This is the one. And now I'll do one more processing here. And that is simply suggesting it, go for this thing. Just give it another shot. If you're having any specific stop word left, remove that also. And if the word is literally there, I mean, like it should not be empty. So now it is removed. And one more thing I should be doing here is, and W is alpha. Means I wanted the alphabetical stuff only, nothing numerical. So I have used the is alpha function and that removed the 2 as well, the numerical 2 as well. So this is quite effort taking process. I mean, like we have done multiple things together. Like I have clubbed it with the, this list comprehension thing. A lot of functions have been like carried out in one line itself. But in summary, if I say we have sentence, like we tokenize them, then we have words, we tokenize them. And from the words, I've removed the stop words, I've removed the punctuation. And then I just, for a double check, I just remove the stop words again in case of removing the punctuations. If any stop word was left, we can remove those. And then after, I just checked out like if the word was really present and if that was alphabet only. Now it looks like I've got all the text in my particular sample text. So this is little pre-processing I have done. I'm not doing any lemmatization or stemming as of now. I'm just doing it very straightforward with the text. Now, I just want to perform this entire process on my like whole data, like whatever text pre-processing I'm thinking of. And that was like by creating some bag of words. For each and every message, I wanted to fetch these words and just wanted to create a kind of pivot table for that. So it is going to be a very time-taking process. So firstly, let me talk about what I'm really going to do here. Here we did the text processing, pre-processing, I should say. So this is what we realized we could do. Now I'm thinking of creating the bag of words. So this can be done with the help of from sklearn dot preprocessing dot text. I think I'm missing some text. Not yet. Feature extraction. Sorry. So feature extraction. So feature extraction text import count vectorizer. This is what I want. Now, after this count vectorizer, I would just create a little CV for this count vectorizer. I'm creating an object for this count vectorizer class, firstly, and telling it we're going to have some data inside, and like definitely a lot of processes will be carried out inside. But as of now, I've just created that. Let me show you again what sort of process I'm really carrying out here. This is the count vectorizer thing, and we'll be creating it. Then we'll be providing our data into this. And whatever data I'll be providing to it, I just need to make sure like it is having all those words and stuff around, because it will be doing automatically all the process. So getting back to this, create the bag of words, cv.fit transform, and providing my data to it. This should be df message dot apply text preprocess. I think they should do it. Let's give it a try. It has. Actually, I missed this print, so I should have removed it. I made a little mistake. Let me just correct myself first. It's not going to work out at all because I wanted to return it, not just print it. So let me just stop the process. We'll execute this function once again. This is returning. We'll create the count vectorizer once more, and now I'm expecting, because this is something it will be doing, like breaking down each every word. It seems like it is being done, but I wanted that to be returned. So just hitting that again. I'm waiting for it. It might take some time, so let's just wait for it. So now it is done, and let's just find out what we have really got here in this BOW. It just suggests like there were 5,568 messages, and for those it has obtained 7,694 unique words in total. And that's like sparse metrics. So I would be just converting that to a data frame. So we rather just see what is really the bag of words. So I'm hitting that. It's converting that to an array and creating the column names over there. Let's see just if it works or not. It does. And what really came out for us is this. So it's just suggesting me we have got different words all around. It's like some very odd kind of things, but they were actually present in our messages. So it was like obtained. Abdomen was like a proper word. Zebra, zeros, zong, zindagi, those are Hindi words as well. So it is like whatever words were there, they're like categorized now. Now, what am I interested into? This is like the sample data. We are interested into creating the further processing over it, like whatever the counts have come out. Like here, I could see like all zeros, but let's just extend it further. If I could just talk about like 30 messages probably. If I could see any one of them having any count, doesn't look like, but it is surely having some counts. But to see them, let's just try that out again. No, it's not visible because they're having 7,000 plus words. So it's not necessarily each and every word would be present in each and every sentence. So I mean like every message, but still I'm just hoping. No, it's not going to show me multiple values right here. So just forget about it because it is definitely having some data, and then I can tell you about, like if I talk about the sum, it will be surely providing me each and every word is having this many number times. Like AA, that came for once in all those like 5,000 plus messages. It came from once only. Similarly, Athi, this word is like something which came for 6 times. Similarly, I would be having a lot of other words and like their repetitions. I could find out the maximum one. It is like 580 times. I don't know which word it was, so I can obtain that. It was 930th message, and it could be. Let's just check it out once again. Like, what was that really? We obtained the sum, and we wanted to see the arg mix. It's not showing what I was like really expecting up. 930. No, it's not the case. So anyway, like that's something we've been getting here, like all the messages. Now I'll be thinking of creating the TF-IDF vectorizer here. TF-IDF from my data, because this is the final step that we should be carrying out. And after that, whatever data set I'll be prepared up with, I'll be going with the machine learning process. So how would I be doing this thing on my BOW? It's like simply asking it, firstly create the TF-IDF stuff, and let's definitely import that. So I'll do this here from my skill learn dot feature underscore selection extraction, sorry, dot text import TF-IDF vectorizer. It is done. I'll create that TF-IDF vectorizer. Did so. Now we'll just fit that up. TF-IDF dot fit transform, and that should be my data. Now, what kind of data I'm supposed to provide to it? I should have stored it somewhere. It will again take time. I just go with this, or do we have the different way here? Doesn't look like we have to be doing it. Anyway, let's do it. Should have stored it somewhere that I just missed in this line itself. Would just do it now, maybe. So now I'm doing it in this line. and then after I'll pass in this docs here. This will apply that TF-IDF, on the entire passages. So instead of creating the bag of words, it will create the term frequency inverse document frequency table. A similar pivot table it will be creating. Similar sort of structure would be coming out, but the information would be different now. Not the counts. Instead, we'll be getting the TF-IDF values. So let's just wait for that another 5 minutes or so. So it is done. Let's just fit the data, and it creates that sparse matrix for me. A similar kind of sparse matrix it is, so similar kind of approach I will use to get the data frame out of this, like that. So this time I'm just naming that to TF-IDF DF, and that too is like going to come out from that TF-IDF to array. So as I'll be asking it, just bring that TF-IDF dot get feature names. So the similar approach. Okay, I guess I missed something here. Oh, I didn't store it. I just missed it. Let me just store it first. TF-IDF D. I'm just storing it. Missed it. So I did TF-IDF DF, and this is again the similar story, but now it would be having the TF-IDF values there. Again, they are like very less common words, so not visible here at all. Like the values looks like 0. The previous values are also looking like 0, but they're not 0. I've shown you they're having some values inside, but very less frequent values were there. So I can just give it a shot, like if I could get TF-IDF TF and there's some of this. So you might see the TF-IDF value for double A word is this one. For the other words, this is the case. So I'm thinking of printing some 30 values or so. So for each and every value, I see like ability, this is the word, and it's having a TF-IDF values like 0.815. Similarly, if I talk about, let's say, abdomen, it's having 0.30. Abbey, this is 0.55. So for each and every word, they have created like this matrix, and it shows the values in terms of the TF-IDF. And this looks like feature to me because 0, 1, 2, 3, the numbers, they are suggesting the message. And if I do have this thing as like message, I can just bring on my type column here and use that up like as a label of this. These are the features we've obtained, and I've got the labels as well. So I can straight away ask it, can you just do the machine learning over this data now? So guys, this is the data set we have prepared. Now I'll do the machine learning over this. And how can I do this? Firstly, I need to prepare my data. So data preparation has to be done in definitely a better way. Like I needed the X-train, Y-train sort of thing. So I'll break down my data. sklearn.model_selection, import train test split, sklearn it was, sklearn. So X-train, X-test, Y-train, Y-test. Brought up from this train test split. Now what is my X? This is going to be TF, IDF, DF. This is my data frame. That would be treated as X. And what is going to be my Y? It is going to be the type of the messages. So I'll be telling this thing. Then test size, it's keeping it 20%, setting up a random state just for a fixed sort of splitting every time when I run this same code. So I did, and it just got splitted. Xtrain.shape, if I check it out, it suggests like 4,454. And if I check out the shape of my X test, it is broken down with 20% of the total data, that is 1114. So it looks like done to me. All I need now, just this is the data preparation, I should say. So just putting up a heading here, data preparation. And next thing is like applying any particular algorithm. So yesterday we used the decision tree algorithm. So let's just bring that up firstly. Decision tree. Like just checking out if it is going to work or not. Well, here. So creating the model tree, but before that I need to import it. So doing it from sklearn dot tree, import decision tree classifier. Also, I'll be doing the ensemble technique here. So I'll do this ensemble random forest classifier, and we'll wait for it to build up by doing this decision tree classifier, and just straight away asking for the X train, Y train over it, and just creating another model known as random forest. So hitting that name and thinking of printing the score, not doing much of evaluation, just simply printing the score for the decision tree on training score, and it should be modeled tree dot score on X train, Y train. Similarly, X test, Y test. This has to be testing score, and so as for the random forest. So just naming that as RF and going with this RF, RF. Let's say that. So I'm going with default parameters here. No, parameter tuning I'm doing as such. Just doing it with the default values only, just to see what really comes out. Today we are having continuous data, so we could surely try with the criterion as the other one, entropy, but let's just see what really comes out.
We got the scores here, and I'm just doing it again because I missed that 100 multiplication there. So let me do it quickly. So it came out like as always. Training score is higher in decision trees always because they tend to overfit, and the test score is also very good, 96%. And in case of random forest, this is 98% approx. So this is so good actually. And my model, like whatever I have created, is going to definitely do well with the random forest one. Now I have one more approach here, and that is the naive base. So I can do with that thing as well. This particular algorithm works with the help of the Bayes theorem itself. What was that? This is the one. We do see this in our probability theory a lot. Like when we create the posterior probability, the probability of A being true given B is true. So a dependent conditional probability, what we used to say. So this particular Bayes theorem was used to predict the, like any particular outcome. And this is quite useful whenever we do the text classification, because Bayes theorem is based on like the probabilities, and here also we were calculating the values, the TF idea. They were also itself like kind of probabilities, the term frequencies, the inverse document frequencies. They were very much related to the probabilities itself. So it could be like quite uh, you know um, good option if you could really go with that. But never forget that like when we do the decision trees, they also have the attribute selection measures that depends on like entropy and like Gini index or like information gain. They were also working up on the probabilities itself, because the entropy calculates the probability. So both the algorithms, like the trees and Bayes terms here, are going to help us out. So I'm just preparing one more model here using the naive Bayes, but this is again very interesting factor here, because in sklearn they have provided us three different naive Bayes approaches. So what are those? I'm just bringing those up. First is the Bernoulli, that is the binary classification stuff. Second is multinomial, like for multiple classes. And third is Gaussian, the Gaussian distribution if we get the data. So I'll use all those B and B. Bernoulli, I guess. Will ask it to fit my data, explain, my train. Similarly, I'll do that for the multinomial and Gaussian. So I'm just hitting those up, multinomial and Gaussian here, and we'll be just waiting for them to get trained, and will then be printing their scores. That's like trained already. Just naming those now. This is B and B. So B and B. Second one is going to be the MNB, multinomial naive Bayes, and last one is going to be the Gaussian one. Definitely, it should be behaving well for the Bernoulli one, but we still just want to check it out whether it's really doing it or not. So B and B, it says, and we just do this laborious work here quickly. M and B, M and B, and this has to be G and B. All right, this looks good to me. Let's just hit that. Here we go. And what is the outcome I'm seeing here? Like when I compare that with my decision trees and random forest as well, Bernoulli NB is actually having a better training score, better in terms of it's not overfitting, just like the decision trees. Rather, it's like showing me 98 score, and in case of test score, that is also like better. Not as good as the random forest one, but it is like definitely a very good side. Very much difference, very slight difference. Multinomial NB is also doing good, but not as good as Bernoulli one. Gaussian NB is not good here because this is not the desired distribution of data here. But yes, this is what I could obtain and like really rely upon. This Bernoulli NB is what like the recommended approach when we are doing the binary classification of text. And definitely the random forest you can try if you wanted to go with the tree algorithms. So this is all I could say, guys. Like if I had a text like this, I could surely, do a lot of efforts with the things, and somewhat this is I'll be getting in the end. So that's all from my side. Like if you have any queries in this thing, whatever I've done here, you can ask me up now. And I'm a little concerned with my laptop's battery. Actually, I've forgotten my charger in my office, so it's not too much right now. So please ask me if you have any queries.
Sir, if we want to know that the list of libraries the Python have, from where we get the list of libraries according to the areas?
Well, let me just tell you one thing. It is PyPy. That's like the official website. There you can get the Python package indexes, like what are the different libraries available there. But again, like your question is slightly,
Like for the
still
computer
kind of,
vision, which kind of
yeah,
library
I'm at
for the
for
NLP?
computer vision, we have OpenCV. We have got definitely Keras, and we have got SK image. But these kind of information cannot be obtained from the official websites. Rather, the Stack Overflow and the forums would be helping you out, because there are no shortcuts of knowing this. This is like simply you need to be searching over internet, like what are the common libraries that can be used for the purpose. But so computer vision, you can definitely go with OpenCV, SK image, and the Keras. That will be creating the deep learning models for you in the end. But this is the place, official place from where you can just obtain all the libraries, like whatever are the available things out there.
Okay. Like for the information, we have to go for the forums.
Yeah, definitely. Means like you need expert comments over there. There are no documentation mentioned domain specific, so you need to be going with the experts comments. Like if you wanted to like know from me, so I could tell you like these are the things. So if you don't know me, then you can simply ask Google. It will be showing the forums for you.
Okay, sir.
Yeah. Any further queries? If anybody having, please ask me up. And surely, I just would like to mention here, like any particular point of time, if you guys feel like stucking into particular area, because whatever I've done, it would have been definitely at very fast pace. It's not easy to fetch up continuously from the very step that I've done. So anytime you feel like connecting again, we can discuss the things. Like we've been already doing these things. The computer vision, the NLPs, these are like key domains I've been like already working with from like quite a lot of time. So we can anytime like get in touch with that.
Yes. Any questions from anyone? Anyone? Okay, I guess no queries. Thank you, sir, for the wonderful session we had in the morning.
Thank you, ma'am. Thank you, ma'am.
We will definitely use it and we will get back to you if we'll find any problem there.
Sure,
Thank
sure,
you.
sure. Thank you.
Thank you.